Good morning, ladies and gentlemen. This is Mr. Rowe. We're taking a look at Geometry Part A, Lesson 1. And in this little recording, we're going to focus on midpoints and segment measures. So remember that we talked about some postulates in the lesson as you read through the lesson. So our first postulate that we're going to focus on is the ruler postulate, which says that you can pair any point on a number line or on a line with a coordinate. So for example, I've got a little picture right here. A is paired with -9, E is paired with -2, E or D with 0, so on. So we can pair any point on a number line with a coordinate to identify where its location in space is. We're going to use that to help us find the midpoints of segments. So for example, if I was looking at DB right here, I can use the ruler postulate to help me figure out where the center of that segment DB is. And then we're going to look at the segment addition postulate. Segment addition postulate says that if you have 3 points that are collinear being on the same line, and let's say A, B, and C, and B is between A and C, then we can take A plus B, or AB, add BC, which is the distance of those two, and that together will equal the distance from A to C. So we're going to use these to help us find variables and then segment lengths. Let's take a look at exactly what we're doing here in this lesson. So here's our first example. We're going to focus on this line segment that would go from A to B. So from right here to right here. And we're going to find the midpoint of the segment. So how do we find a midpoint? Well, midpoint is basically the average of the coordinates of these 2 points. So remember, we got the ruler postulate, which says that A is -8. And then we've got B is 4. So we're going to add these 2 together, which will give us -4. And then to find the center, we're going to divide that by 2. And the signs are important here. In this case, -2 would be the midpoint. So I'm going to label the midpoint. I'm going to use, let's use green. And there's my midpoint right there. And let's label that with L. So what that means is that from A to M would be the same distance as from M to B. So if we count 1 or 2, 4, 6, if we count from -2 to 4, 2, 4, 6. So we've got our same measures there. So that is how you find the midpoint. So we're going to add the coordinates. And then we're going to, that's the first step, and then we're going to divide by 2. So we add the coordinates, divide by 2. So a real simple process. All right, let's take a look at another example here. All right, so we're still finding the midpoint of AB. So this time A is at -10. And B is at, it's in between these 2. We're going to assume whole numbers and not decimals. So we're going to assume that B is at 3. So to find the midpoint, remember our 2 steps. Step 1 is to add the coordinates. So we're going to add -10 plus 3, which gives us -7. And then step 2 is to take that value and divide it by 2. So that means that the midpoint of segment AB is at -3.5. So now we're not going to be able to accurately place that on the number line, but it's going to be somewhere closer to 4 than it is to -2. And that's going to be our midpoint. And that's all you got to do to find the midpoint. Now, we'll talk about midpoints later on again, but for right now, we're just looking at number lines. And that's how you find the midpoint. We're going to focus later on in the lesson on how you find the midpoint of a segment in the coordinate plane. So we'll do some coordinate geometry later on. So now let's take a look at the segment addition postulate. So here is a sample segment addition postulate problem. So here we're asked to find the length of AB and BC. Well, here's AB, here's BC. We don't know those values because they are expressions. So we're going to use the given information here to set up an equation and then solve the equation for X. So first step here, set up the equation. Step 2, obviously, will be to solve for X or solve the equation. And then step 3 will be to answer the question. All right. And let me try to clean that up a little bit so it looks a little better there. So what's the equation going to be? Well, if we recall what the segment addition postulate says, it says that AB plus BC will equal AC. So here is AB, 6x plus 5. So I need to add AC, or BC, excuse me, I'm going to add BC. BC is right here, 3x plus 2. And then that equals AC. And we know that AC goes from here to here, and that length is 70. So that is a multi-step equation. So we're going to go through the multi-step equation process that you learned in probably pre-algebra, focused again on an algebra 1, and now we're looking at it here again in geometry. So step 1 here, if you go through that process, you distribute, and then you combine like terms. We don't have any parentheses, so there's no distributing involved. So we just need to move to the like terms. So here are my like terms. So that's going to be 9x plus, and here's my other set of like terms. So 5 plus 2 is 7, and that's going to equal 70. And now it's just a two-step equation. We're going to subtract 7 from each side. So that gives me 9x equals 63. And then we're going to divide both sides by 9 to give me x equals 7. Now, x equals 7, that's just step 2 of the process. So don't stop there. Now you've got to answer the question. The question is find A, B, and BC. Remember that AB, without anything around it, means the distance from A to B, and BC means the distance from B to C. So we're going to use x equals 7 to help us do that. So I'm going to section this off a little bit. So here is AB. I know that AB, 6x minus 5, or 6x plus 5. I'm going to replace x with 7. And then solve. 6 times 7 is 42. 42 plus 5 is 47. So AB equals 47. Okay. And then we're going to find over here, we're going to find BC. So again, BC, we know right here is 3x plus 2. We're going to use that x equals 7 again right here. And we're going to replace 3 times 7 plus 2. 3 times 7 is 21. 21 plus 2 is 23. So BC is 23. Now we can check our answer here because 47 plus 23 has to equal what? Has to equal 70. So if we add that together, we see that we do indeed get 70. So here are our answers to this problem. And that's the process. Set up the equation using the segment addition postulate, solve the equation, and then answer the question. You're going to be asked to find the lengths of one or more segments. All right, let's take a look at this next example. A little bit different here. This time we're told that AB right here, we already know this one, it's 15. But now we're asked to find AC, which is the full length. And then the short length right here, BC. So those are the two things we're trying to find. So we're going to follow the same process. Step one, set up the equation. Well, I know I have to find AB plus BC, and that has to equal AC. Now, you use the letters that you're given in the problem. So here is my equation. My equation is going to be 15 plus 5x plus 6. And then that's going to equal 7x minus 33. So again, follow the rules for simplifying or solving an equation. We're going to combine like terms first. My like terms are 15 and 6. 15 plus 6 is 21. So this would be 5x plus 21 equals 7x minus 33. So now the next thing I need to do is to get the variables to one side using addition or subtraction. Now, go back and review your algebra rules if you don't remember all this. So I'm going to subtract 5x from each side. Now, why did I subtract 5x? That's just my general rule. I like to get rid of the smallest thing from whichever side it's on and move it to the side where the larger thing is. 5x is smaller than 7x. So that gives me 2x minus 33 equals 21. I'm going to add 33 to each side. I'm running out of a little bit of space here, so I'm going to zoom out just a little bit. Move it up just a little bit so I have some more room. And so what I've got now is I've got 21 plus 33, which is 54. And that's going to equal 2x. I'm going to divide by 2 to give me x equals 27. Now, yeah, remember, x equals 27, that's just part of the process. Don't stop until you've answered the question. The question here is to find AC and BC. So let's find AC first. Remember, we're going to substitute the value we just found into the expression for the part and then simplify the part. So AC is 7x minus 33. We're going to replace x with 27. So I've got 7 times 27 minus 33. You got your calculator and you're not sure, pull that calculator out. We're going to do 7 times 27. That gives me 189. And 189 minus 33 is going to equal 156. And then we're going to find, over here, we're going to find BC. Okay, BC is 5x plus 6. Again, we're going to replace x with 27. So 5 times 27 plus 6. Clean that up a little bit so it looks a little better. Again, if you got your calculator, pull it out. 5 times 27 gives me 135. 135 plus 6 is 141. Now, again, you can check this. The total AC is 156. I know that BC, or what I've got for BC, is 141. I know AB is 15. So if I add 141 plus 15, I should get 156. And I do. So I know I've got the right answer here. So my two answers are 156 and 141. All right, final example here. So this time we're asked to find the lengths of AB, BC, and AC. Now, why is that? Well, if we look at everything we're given, we're just given everything as an expression. We're not given the value of any segment. So we're going to go through the process. AB plus BC has to equal AC. So we're going to set up our equation. 4x plus 7 is AB, plus BC, which is 5x plus 10. And then that's going to equal AC, which is 12x minus 16. Orders of operations are simplifying expression rules, simplifying equations. I'm going to combine my like terms. 4x plus 5x is 9x. And then 7 plus 10 is 17. And then we're going to move the variable to one side. So we're going to subtract 9x. And so that gives me 17 equals 3x minus 16. All right, running out of space here again. So I want to zoom out just a little bit and move it. Two-step equation now. We're going to add 16 to each side. That gives me 33 equals 3x. We're going to divide by 3. And then I know that x is going to equal 11. And again, x equals 11. That's just part of the process. What we've got to do is we've got to figure out what AB, BC, and AC are. So we're going to start off with AB. So here is AB. I know that AB is 4x plus 7. I'm going to replace x with what we got, which is 11. So 4 times 11 plus 7. That's going to give me 44 plus 7, which is 51. Okay. Next, we're going to find BC. Okay, BC, 5x plus 10. Again, replace x with 11. 5 times 11 is 55. 55 plus 10 is 65. And now what we've got is we've got A, B, and BC. If we added those two together, we got 51 and 65. So let's take a look at that. 51 plus 65. That's 116. So that means when I calculate 12x minus 16, I should get 116. I'm going to go ahead and check it out just to make sure, because if I've got something wrong, I want to be able to go back and solve it correctly. So we've got 12x minus 16, that is AC. We're going to replace x with 11, so 12 times 11. 12 times 11 is 132. 132 minus 16 does indeed equal 116. So there are my three answers. So there's AB, BC, and AC. All right, so I hope this helps you get started with the lesson. So for midpoints, just a quick review here. We're going to add coordinates. And then we're going to divide by 2. And that's going to give me the midpoint of any line segment. And then segment addition, or segments. We're going to first set up the equation using the segment addition postulate. So that's AB plus BC equals AC. Number 2, we're going to solve the equation. So that's solving for X. And then finally, step 3, we're going to answer the question. So I hope this helps you get through the problems in your assignment on these. If you need additional help on the concept, please let me know through a teacher message or set up a help session for an appointment.